There's another important cost that we need to define. We love thinking on the margin. We've seen this term marginal cost before, but let's take a closer look at it now. Your marginal cost is your change in total cost from producing an additional unit of output. So your marginal cost, just the change in total cost divided by that change in output. We can also write it as follows. The change in total cost can be broken down into the change in fixed cost divided by the change in variable cost over the change in output. Well, we know that fixed costs do not change as output changes. So that term's equal to 0. Variable costs do change as output changes. We saw that in a previous slide. So another way you can define marginal cost is it's the change in variable cost divided by the change in output. So marginal costs are changing because you have to buy more variable inputs to produce more of the product. And what this graph does is use the information from the previous slides to show that these two definitions of marginal cost are equivalent. Just reminding you that our fixed costs are 100, so the difference between these two columns here is going to be equal to fixed cost, but marginal cost is either the change in total cost divided by the change in output, so $70 for the first unit, change in total cost for the second unit, $50, so how much extra did it cost to produce the second unit? $50 more, and so on. What about the seventh unit? When I produce the seventh unit, total costs increased by $140. So the marginal cost of producing the seventh unit is $140. We could have also used variable cost, taking advantage of the fact that marginal cost is also equal to the change in variable cost divided by the change in output. So what's the marginal cost of producing the second unit? You look at the change in variable cost. $50 extra worth of variable inputs were needed, and so the marginal cost of producing the second unit, $50 more. Marginal cost of producing the third unit, how much extra to produce the third unit? $40 more, and so on. So marginals apply to an individual unit. Total cost of producing 3 units, $260. Total variable cost of producing 3 units, $160 worth of variable costs were used. Now there's a special relationship between average cost and marginal costs. So I've drawn in this dotted line here to show you where they intersect, and that is going to be at the minimum point of the average cost curve, which remember has that U shape. Why is this so? Whenever marginal cost for a given quantity, if marginal cost is less than average cost, then average cost is going to fall. If the average cost of producing the second unit is roughly a little over $100, but the marginal cost of producing the third unit is less than $50, then what's going to happen to the average? The average will fall. Sometimes students can relate better to this if they think about their GPAs. If you currently, through 2 exams, let's say, have 100 average, well, what's going to happen to your average if you get a 50 on the next exam? Your average will fall. Even if you do better and get, let's say, a 75 on the following exam, as long as that 75 is below your current average, your average will fall. But what's going to happen if marginal cost is greater than average cost? So for these points to the right of where this intersection happens, marginal is greater than average for any given quantity. If that's the case, your average cost is going to go up. If you want to bring your average up, then you have to do better on the next exam. If on the margin the cost of producing another unit exceeds your current average, the average will start to rise. And so it must be true that the marginal cost is going to cross the average cost curve at the average cost curve's minimum. Now let's plot all of these curves together. You might wonder why all this nonsense. We will need to understand how costs change as we produce more and more output in order to make our decision about how much output to produce in order to maximize our profits. So here's my average cost curve. My average variable cost curve must lie below it because remember, average cost is equal to average variable plus the average fixed. So the difference between these two curves at any given quantity is equal to the average fixed. Notice that the distance is getting closer and closer as we produce more output. That's because we spread out our overhead. And finally, my marginal cost curve comes up through the minimum of the average cost curve. It also comes up through the minimum of the average variable cost curve. Usually, because it's just a lot easier to visualize, we omit the average fixed cost curve.